You get into bed, you close your eyes, and your brain immediately decides this is the perfect time to replay an embarrassing thing you said in 2014. You roll over, you check the time. You immediately regret checking the time. You think about what you have to do tomorrow, then what you have to do the day after that. Then somehow you're planning a conversation that isn't happening for another 6 months. Eventually, somehow, none of that matters anymore, and you're out. Here's the part almost nobody thinks about. The second you fall asleep, your brain does not turn off. It switches into one of the most complex, tightly scheduled processes your body ever runs. A precise sequence of stages, each one doing something completely different. Repeating on a loop several times a night, cleaning your brain, repairing your body, sorting your memories, and generating the strange, occasionally unhinged movie you call a dream. All while you're doing, from your perspective, absolutely nothing. So tonight, we're going to actually walk through it, stage by stage, what's actually happening in your brain while you think you're just lying there. Sleep isn't one long uniform thing. It's actually 4 distinct stages. 3 stages of what's called non-REM sleep, and 1 stage of REM sleep, where most dreaming happens. You cycle through all 4 in order about every 90 minutes. Then the whole cycle starts over again. Most people run through this cycle 4 to 6 times a night, which means most nights you're not having one dream. You're having several. You just don't remember most of them. Here's the part that makes this genuinely interesting. The cycles aren't identical throughout the night. Early in the night, your cycles lean heavily toward deep sleep. Later in the night, they lean heavily toward REM sleep instead. Your body is running a different priority list depending on the hour. Let's go through each stage individually and figure out why. Stage 1 starts the second you actually drift off. It's incredibly short, usually just a few minutes. Your brain waves start slowing down from your normal waking pattern. Your muscles start to relax. This is also famously when the hypnic jerk happens, that falling sensation that makes your whole body twitch awake. Nobody fully agrees on why it happens. One leading theory is that your brain is double-checking your muscles are actually relaxing on purpose, not because something's wrong. Stage 1 is also incredibly easy to interrupt. A noise, a light, someone asking if you're awake, and you're right back to fully awake like nothing happened. Stage 2 is where you actually spend most of the night. Something like half of your total sleep time happens here. Your body temperature drops slightly, your heart rate slows down, your brain starts producing short, sharp bursts of activity called sleep spindles. These spindles seem to play a real role in memory processing, specifically protecting stored memories from getting overwritten by new information coming in. You're still fairly easy to wake up here, but it takes a bit more than stage 1 did. Your body is quietly preparing for something much deeper. Stage 3 is deep sleep, also called slow wave sleep. And this is where the real physical maintenance work happens. Your body releases the majority of its growth hormone for the day right here. This is what repairs muscle tissue, rebuilds cells, strengthens your immune system. If you've ever heard that kids need more sleep to grow, this stage is a big part of why. This is also the hardest stage to wake someone up from. If you've ever woken someone up during deep sleep, you've seen the confused, almost drugged look on their face. That grogginess has a name: sleep inertia. Your brain genuinely needs a few minutes to catch back up. Deep sleep is also when the brain runs a kind of internal cleaning cycle. Cerebrospinal fluid washes through brain tissue, flushing out waste proteins that build up during a normal day of thinking. One of those proteins, beta amyloid, is strongly linked to Alzheimer's disease when it builds up too much. Deep sleep is quite literally your brain taking out the trash. This is also when sleepwalking tends to happen, if it happens at all. Not during dreaming, during this deep, low activity stage. And now, the strange one. REM sleep. REM stands for rapid eye movement, because that's literally what's happening. Your eyes are darting around rapidly behind closed lids. Your brain activity during REM looks remarkably close to being awake. Fast, active, busy. This is the stage where most vivid dreaming happens. Full storylines, random people you haven't thought about in years, occasionally your teeth falling out for no reason. Here's the wild part though. While your brain is this active, your body is almost completely paralyzed. This is called REM atonia. Your brain deliberately shuts off signals to most of your major muscles, which sounds unsettling, but it's actually a safety feature. It stops you from physically acting out whatever chaos is happening in the dream. In rare cases, this paralysis system doesn't fully engage, and people briefly wake up while still fully paralyzed. That's sleep paralysis, genuinely real, genuinely harmless, genuinely terrifying to experience. It resolves on its own, within a couple of minutes every time. REM sleep isn't just about dreaming either. It plays a major role in emotional processing. Your brain appears to use this stage to work through emotionally intense experiences from the day, sort of like emotional filing, without the panic of experiencing it live. REM sleep is also deeply tied to memory consolidation, moving information from short-term storage into longer-term memory, which is a big part of why sleep and learning are so closely linked. Pull an all-nighter before a test, and you're skipping the exact stage that helps lock that information in. So why does the balance of these stages change as the night goes on? Early cycles prioritize deep sleep because physical repair is time-sensitive. Your body wants to get the muscle repair, immune boost, and brain cleaning done as early as possible. Later cycles shift the priority toward REM sleep instead. Once the physical repairs are mostly handled, the brain shifts toward memory and emotional processing. This is part of why waking up too early can feel so specifically rough. You're not just missing sleep in general, you're disproportionately cutting into the REM-heavy stretch that happens later in the night, the stage responsible for a huge chunk of your memory and emotional processing. So what actually happens if this whole process gets cut short repeatedly? Not dramatically, just a little short, night after night. Your memory consolidation takes a direct hit first. Information you learned that day doesn't get locked in properly. Your immune system takes a hit too. Studies have shown reduced sleep leads to a measurably weaker immune response. You get sick more easily, and it takes longer to recover. Emotional regulation gets noticeably harder too. Small annoyances start to feel much bigger than they actually are. That's the emotional processing role of REM sleep, quietly not getting done. Reaction time slows down measurably too. This is part of why drowsy driving is genuinely comparable to drunk driving in the data. And here's a genuinely unsettling one: microsleeps. Brief, involuntary moments of sleep lasting just a few seconds, while your eyes might even still be open. Most people who experience them don't even realize it happened, which is exactly why severe sleep deprivation is so dangerous behind the wheel. So let's go back to you lying in bed at the start of all this. From the outside, it looked like nothing was happening. Underneath that stillness, an entire operation was running. Stage 1, easing you in. Stage 2, protecting your memories while your body cools down. Stage 3, repairing tissue and cleaning your brain from the inside out. REM sleep, sorting memories and processing whatever your day threw at you emotionally. Then the whole thing looping again and again several times before morning. All of it completely automatic. You never had to manage a single second of it. Your body has been quietly running this exact routine every single night for your entire life. So tonight, when you get into bed and your brain starts replaying something from 2014 again, just know that right after that, something genuinely impressive is about to happen. If this made you appreciate your pillow a little more, hit subscribe. Thanks for watching. Now go get some actual sleep. You've clearly earned it.